Now we're gonna look at some example for solving the logarithm equation using some of the property. The most useful for property that you will see is when you have a logarithm equation, you can write that back to the exponential equation. So keep in mind that if you have the logarithm equation y equal log base a of x. This is actually equivalent to a to the power y equal to x. Okay, equal x. So the two are equivalent, so you can write back and forth. Okay, so this is the logarithm form, and this is exponential form. So logarithm form, and then this is exponential form. All right, so now let's take a look at how do we use that to solve an equation. So I have logs x is equal to, oops, but this expression, there's no base, okay? I don't have the little number down here. So when you encounter a logarithm that have no base, the base is actually 10. That is called the common logarithm. Common logarithm. Logs base 10 is equal to log 10. Log, okay, with no base. So log with no base is actually log base 10. So I have log base 10 right here. So this is base 10. So we're gonna take 10 raised to the power 2 and then equal to x equal x. So my answer will be x equal 100. So logs of 100 is actually equal to. You can actually use a calculator to double check your answer. If you see the logarithm right here, log, this is the logarithm, right? So in the calculator, when you press log, there's no base, but we know that's going to be base 10. And now let's press 100. Log of 100 is equal to 2. Okay, so logarithm of 100 is equal to 2. So that is how to solve the equation. Now let's take a look at the exponent. So in this example, you have the exponential form, okay? But you want to solve for x. We won't be able to write it at the same base like the example above. We cannot do, 3 equal 3 to the power x, then x equal 1. This is 5. 5 cannot read in the base 3. So what I need to do is you can apply the idea of the definition of logarithm. The exponent can be written in the logarithm form. So the base here is 5. So I will have log. The base is 5. Okay, this is the base. So this is the base. So log space 5 of what? Log space 5 of 3. Log space 5 of 3 is equal to the exponent. So the exponent is the logarithm. So the exponent is the logarithm base 5 of 3. Okay, so that is our answer. So this x will be log space 5 of 3. So answer will be log base 5 of 3. If you want to evaluate in your calculator, some of your calculator can be can put in the base into the calculator, but some of the calculator can't. Okay, so you can leave it at exact. If you want to approximate, then you're gonna take log base a of b is same as log b over log a. So it's going to be same as log 3 over log 5, which is over log 5, and that is about 0.6826. Okay, so your x approximate about 0.626. If you take 5 to the power x, if I putting this x into this value for my x, I will have 5 to the power this value. And if I enter, it's actually equal 3. So 5 to the power of 0.6826061945 is actually equal 3. And this is one of the way to solve the exponential equation when you cannot read in the same base. Let's continue. Take a look at this one. This one, the difference between this one and the one above, I have an extra -3 on the equation. So make sure whenever you solve an exponential equation, you want to solve for the exponential term first, okay? So whenever you solve an exponential equation, you want to solve the exponential term first. So it means I need to isolate 4 to the power x first by adding 3 on both sides. And I will have 4x equal to 10. Now in this case, I won't be able to make the 4 and the 10 with the same base. So we're gonna do the logarithm definition, which is logs exponent, the exponent. The exponent x is the logarithm where the base is 4. The base is 4, and the argument of the exponent is 10. And you have log space 4 of 10 is equal to x. All right, so let's take a look at this one. So this one, same thing. In order to solve equation, we need to isolate the exponential term. If you solve logarithm equation, we need to isolate the logarithm form. So we isolate this. We will have log space 5 of x will equal to 10 minus 4, which is 6. And then we're going to apply the definition. We will have 5 raised to the power 6 because the exponent is a power. So 5 raised to the power 6 equal x. And 5 to the power 6 is 5 to the power 6 is 15625. Okay, so our exponent is our x value is 15625. There's some more property of the logarithm that you may want to pay attention to, which is the product, the logarithm of the products. Okay, so let's say if you have the logarithm of 3 and then you have x y, then we can actually write that log space 3 of x plus log space 3 of y. Okay, so if the argument of the logarithm is a product, you can break them down into the sum. Okay, so or the other way around, if I have log space 3 of 2 plus log space 3 of 4, then I can write that log space 3 of 2 times 4, which is log space 3 of 8. Okay, so we can rewrite back and forth between these properties because they are equivalent. Okay, and these are actually useful for solving logarithm that is a little bit more complicating. Okay, so let's take a look at this one. So in the example 3, I have the logarithm of logarithm base 3 of x plus 3. Adding logarithm base 3 of x minus 3. So look like I have multiple logarithm in my equation. When you have multiple logarithm in your equation, you want to rewrite it first so that you can have the single logarithm and apply the third property to solve. So I'm gonna make this is the plus. So I'm gonna apply the first rule, which is multiply the argument of the logarithm. So far I've been talking about argument. What did argument mean? So when you have y equal log space a of b, this is called the base of the logarithm, and the b is the argument. Okay, so whatever right next to logarithm is argument. So I have the argument here is x plus 3 and this is x minus 3. So we apply the product rule. For the plus, we're gonna have logs base 3 of what? Of the product of their argument. So we're gonna have x plus 3 times x minus 3. And that's gonna equal to the right hand side, which is log base 3 of 10. Okay, and since we rewrite the sum at the product, we can take the last property. The last property is saying that if you have two logarithms that equal to each other, you can then their argument should equal to each other. So I have the argument for the left side is x per 3 times x minus 3, and the right side is 10. So all we have to do is set them equal to each other. Okay, and then we're gonna solve. So let's go distribute. If you remember this property, a minus b times a plus b, it's called the difference square of square. And a minus b times a plus b is actually a squared minus b squared. So it means we're gonna have x squared minus 9 is equal 10. Okay, you're gonna have a first term square minus the second term square, and that equal 10. Now solve for x, we will have x squared equal plus 9 on both sides. We will have x squared equal 19. Take square root both sides. We will have x equal plus and minus root 19. So when you have the answer, you also have to be careful to check your solution whether it's gonna be satisfy the equation or not, okay? Or the other way is to compare your solution with the domain of the function of the equation. The domain here for the logarithm base 3 of x plus 3, we know that x plus 3 must greater than 0. So we have x plus 3 greater than 0. So x must greater than negative 3. And then on this side, we have x minus 3 greater than 0. So x must greater than 3. So you have two of them. You're going to have to take the intersection to see which one is satisfied. So this is negative 3 and this is 3. You need one domain to have everything above negative 3. And the other one need everything above 3. So take the intersection. It looks like this part is the one that's satisfied for both, right? This one is the one that's satisfied for both. So we're gonna take that one. So the domain will be x greater than 3. Okay, so if x must be greater than 3, then I cannot have the negative as my answer. So I will have to take my final solution will be x equal to square root of 19, because x equal negative root 19 is not in our domain. So I cannot put it into our equation.